Hello and welcome to my presentation. My name is Alex Weber. Today I'll be presenting a case study on the recent earthquake in Myanmar. This event is a strong reminder of how powerful tectonic forces can shape human lives and the environment. We'll look at where and why this earthquake occurred, what the impacts were, and what we can learn from it. Myanmar is a country located in northwest Southeast Asia. Here's a quick outline of what we'll cover. First, I'll give a summary of the event itself, when and where it happened, and its magnitude. Then we'll look at the tectonic setting and the seismic data to understand its geological context. After that, we'll discuss the structural, geology, human, and environmental impacts. And finally, we'll reflect on the broader implications. The Myanmar earthquake occurred near the Myanmar and China border and had a magnitude of approximately 6.5. Initially, it was reported as 7.7. It was a shallow quake with a depth of 10 kilometers. The shaking was felt widely across Southeast Asia, causing concern in several neighboring countries. Because of its shallow depth, even a moderate magnitude produced a significant ground shaking. Myanmar lies at the intersection of major tectonic plates, particularly the Indian, Eurasian, and Sunda plates. This region is known for complex plate interactions, including subductions and strike-slip motion. The Sagaing Fault, one of the most active fault systems in Southeast Asia, plays a major role in seismic activity here. This fault accommodates much of the strain between the plates, making the region highly prone to earthquakes. As you can see in the map here, where it's located. Seismographs recorded clear P and S waves, confirming the shallow depth and strike-slip nature of the event. Because of the seismic waves traveled quickly through shallow crust, ground motion was strong near the epicenter. This is why understanding the seismographs is so important. It gives us insight to both the intensity and the type of fault movement. As you can see in the image here, the S waves and then the P wave. And the way the specific earthquake moved was a slip fault, so it was movement along this line that caused it to be so dramatic at the epicenter, which is like the ground level. The earthquake was associated with a strike-slip faulting along the Sagaing Fault system. This fault runs through the central Myanmar and has been responsible for many past earthquakes. Geologically, the area consists of complex folded and faulted crust, which makes it more vulnerable to significant displacements during earthquakes. This structural setting explains why earthquakes here can be so destructive. If you see in the image here, you can see how a strike-slip faulting works by moving side to side, and it causes more destruction on ground level, and people feel it much stronger. Human impacts. Dozens of people were injured and infrastructure damage was reported in several towns and villages. Power outages and communication disruptions made emergency response more difficult. This earthquake highlights how vulnerable rural and less developed communities can be during seismic events, especially when the building codes and preparedness measures are limited. Environmental impacts. Beyond human impacts, the earthquake triggered localized landslides, riverbank collapses, and visible ground deformation. These effects can disrupt ecosystems and make areas unsafe for residents even after the shaking stops. The risk of aftershocks adds to the uncertainty, and recovery for the landscape can take months or even years. This is especially true because it's an underdeveloped country. Broader implications. This earthquake is part of a pattern that reflects Myanmar's tectonic reality. Preparedness and investment in resilient infrastructure are critical to reducing impact of future earthquakes. These lessons apply not just to Myanmar, but also many tectonic actively regions around the world. beyond monitoring, education and early warning systems can save lives. Hope you enjoyed my presentation and my trouble trying to pronounce these different locations. Thank you. Bye.